Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with the Saibono Discovery Center. Okay, today's topic is going to be on circles, angles, and angular movement, which is paper 2. And this topic, it's plus minus 35 marks. So it's plus minus 35 marks. So for you to achieve 35 marks, you must know your formula. And you must read the question and understand it. Now, we are going to look at this topic, which has to do with circles, angles, and angular movement. Remember, we have done part 1 of this topic, where we dealt with the circles and the angles. Now we're going to be dealing with the angular movement. So this topic, as I said, is 35 marks in an exam, and let's see how best we can do on this topic. It's an easy topic. Let's look at the objectives of this lesson. Now, by the end of this session, we want you to be able to do the following. We must be able to calculate the angular and circumferential velocity. So the circumferential velocity is sometimes called the peripheral velocity. So if you see these words, please make sure that you understand these words. So that then you are able to can choose the correct formula. So we've got the angular one, which is going to be the angular velocity, and also we've got the circumferential velocity, and we'll be looking also at the formula there. So we must be able to can calculate that. The next thing that we need to know, we need to apply the knowledge to solve these practical problems, because this topic is very practical in technical fields. So we must be able to can do that. Now let's look at what is that angular velocity that we're talking about. Now, angular velocity is how fast something rotates. So, how fast the body is rotating. So you'll see in the next one we're going to be playing a video, and then you can be able to see what we're talking about here. Can also be defined as the rate of change of angular displacement of the object with respect to time. So in other words, we need to define it as a rate of change. Now you will remember when you're doing your differential calculus, you remember the rate of change there. Now, the measure of angular displacement. So it is also the measure of the angular displacement that was made by the body while the body is rotating. So whilst the body is rotating, then we measure that angular displacement. Okay. Now the units for the angular velocity are revolutions per second. So in other words, here we are going to talk about revs per seconds. Okay. So the units that we're going to be looking at. So that is rev per seconds that we're going to be talking about. Or we can then talk about the radians per seconds. So those two are the same. So if I write my answer as rad per second, or I write it as rev per second, I'll get a full marks there. Please, the units are very, very, very important. We know when you're working on those questions, most of the time you don't write the units. But we sometimes give you a mark for that. But now we want to be a bit, want you to do the correct thing. Please write down the units. Right, now let's look at the formula for the angular velocity. Now the angular velocity is that sign which looks like a W, but it is not W. It is called omega. So from now on, that sign we call it an omega. So it's the sort of a W, but it's called an omega. The other thing that we have there is our theta, which is an angle, and that angle will be in radians over t. So this is one formula that we can use. When do we use this formula? When I'm given the angle of rotation, and I'm also given the time that it takes for that object to rotate. The other formula that we're going to be using is that one, which is 2 pi multiplied by the number of revolutions. So when do you use this formula? when I'm given the number of revolutions. So if I've got number of revolutions, I then use that formula, which is 2 pi n. You'll see most of the time we'll be using that formula in questions that I've been given. But as I say, read the question, understand the question, then from there be able to use the correct formula. The n there will be the number of revolutions per second. Please note that, because sometimes it can be given to you as per minute, then you must change it, the minutes to seconds. So you must be able to can do that. Okay, now I'm going to quickly play you a video, which is a 3 minutes video. Please watch that video, and then from on that video, you're going to see what we're talking about when we talk about your angular velocity. Right.
Good morning. I have invited my family out today to help me with a demonstration. All right, Mom, could you come here? All right, so we're gonna have you stand right about here. And what I need you to do is stay in the spot and turn at a constant angular velocity. Yep, turn. Excellent. You're doing an excellent job turning at a constant angular velocity. Yep, do an excellent job. Just keep moving at a constant angular velocity. Awesome. Good. Evan, could you come here for a moment, please? Could you please stand right next to Grandma? And you're going to put your arm in arm there. Grandma, do the same thing. And Evan, go ahead. Yep, there you go. Doing an excellent job. Good job. And please pause. Kate, could you come here, please? You're going to be right next to Evan. Woo-hoo. And Grandma, go ahead. Keep going. Good. That's good. And if you could please pause. Carrie, if you could come here, please.
Yeah. Ooh, this is getting exciting.
And go ahead, Grandma. Good job, Grandma. You're doing an excellent job. Kate, come on, catch up here. Just a little bit faster. There you go. All right. All right. And, okay. And pause, please. Chris, could you come here, please? Chris, come on over. Right here, right next to your wife. And go ahead, Grandma. Go ahead, Grandma. Are you okay, Grandma?
I'm fine.
Everything good? Everything? Evan, everything good? Uncle Chris, come on! Keep up here. Okay. And you can please pause right there for me. Just pause right there for me. Okay. So the important thing to realize here is if Uncle Chris could actually keep up, you all would have had the same angular velocity. You're all moving through the same number of degrees in the same amount of time. So it's the same angular velocity. However, I think you would agree that something was different, right?
I'm short of breath and evidence.
Anybody have any ideas what was different?
The distance that we were traveling.
So the linear distance traveled is different for each of you, even though the angular distance is the same. So as the radius increases, the linear distance traveled when moving through a circle, which is called arc length, increases. And so you also have a linear velocity when you're moving in a circle, which is called the tangential velocity. And the tangential velocity also increases with the radius. So again, the important piece to realize here is with an increased radius, we have an increased arc length. Again, arc length, the equation, equals radius times the change in angular position. And we also have an equation for tangential velocity. The tangential velocity equals the radius times the angular velocity. And with an increased radius, we have an increased arc length and an increased tangential velocity. And that v sub t equals r times omega. That tangential velocity equals the radius times the angular velocity. With an increased radius, we have an increased tangential velocity. And remember, just like the arc length equation, you need to use radians in the equation for tangential velocity. So that angular velocity needs to be in radians per second. Thank you very much for your help today. Thank you very much for learning with me today. I enjoyed learning with you. Thank you. Come here.
Are you going to check this to make sure we're like underneath?
Well, yes.
Okay.
Thank you very much.
All right.
Very helpful.
It was fun.
May I call the Johnsons and tell them?
Can I go get a hat?
I need to brush my teeth.
Good morning.
Okay, now you have seen on that video. If I can just quickly go back to this to this, you have seen on that video there that when the diameter, when the radius there increases and increases and increases and increases, the faster that guy goes. The faster that guy goes. So the circumferential velocity will be much faster when we increase the radius. So you'll see when grandma was there, then the grandma was moving, the angular velocity was the same with grandma, but then with Lindsay, then you can see that Lindsay was going much faster than the other members of the group there. Right. So now,
good morning.
Let's look at what circumferential or peripheral velocity is. Now, the peripheral velocity is the speed. Remember, velocity is speed. That a point on the circumference moves per second. So, in other words, it is speed. So, when you look at this, the formula for speed, remember the formula for speed will be distance divided by time. Remember the not the DSTV, but the DST, the DST that you have done in grade 9. Remember, your speed, it's equals to distance over time. Okay, so now the distance is measured in meters, and then the time is measured in seconds. So we write this as m/s, which says meters per second. So, or we can write it as m.s with a -1 there. So we know it is going to be meters per second. Right. So now, the conversions, remember the conversions, you must always know your conversions. So with your conversions there, you remember, if I want to take kilometers to meters, then I must multiply that by 1,000. If I want to take meters to millimeters, then I must multiply that by 1,000 also. But if I want to take kilometers to millimeters, that's a long stretch. Remember, 1 kilometer, only 1 kilometer will give you 1 million millimeters. Remember, a millimeter is a very small unit. So 1 kilometer will give us 1 million millimeters. So if I want to go back again there, what do I do? From millimeters to that, I'm going to multiply that. Okay, from there to there, I'm going to multiply that. So when I go back again, I'm going to be multiplying that. Okay, but if I've got 1,000 millimeters, I want to take them to kilometers, I'm going to divide this by 1 million, and then that's where I'm going to get my 1 kilometer. Okay, so this is very important that you know. This is grade 10 work. That grade 10 work is very important because when you read your question, it says, write the following in meters per second. When you're given that as kilometers per hour, then you must be able to can change that. Now, the formula for circumferential velocity is written as v, which is velocity, equals to pi d multiplied by n, or we can use the formula v equals to omega multiplied by the radius. These two formulae are the same. If I can just quickly show you. Remember what omega was? The omega was equals to 2 pi d. So if I come here and then I say I multiply, then I write this down, it will be 2 pi d multiplied by the r. So in other words, so 2 pi n, what am I writing there? So it must be 2 pi n. Okay, so, and that will be multiplied by that r again. So you know that if I've got 2r, that gives me a diameter. So 2r gives me a diameter, so I'm going to have pi multiplied by the diameter multiplied by that, which is the same formula as that. So when I'm given that formula, it's when I'm using that formula, it is when angular velocity is given. I know my angular velocity, then what do I need? I need my circumferential velocity, but then I've got a radius for that matter. Remember on the video that we had that a radius being given, and I have the angular velocity of the grandma, then from there I can just use that formula to get the velocity, the speed at which Megan was running. Now, V, as I said, is the circumferential velocity, and D is the diameter, N is the number of complete revolution. In that case, it was, if they move once, it was one revolution. Right. Now to activities. Before we do activities, quickly let me do the introduction to that. The circumferential velocity, we said sometimes referred as peripheral velocity, so you'll have that. It is the speed when the diameter and the number of revolutions are given. So what should be given? The diameter and the number of revolutions. So remember the formula, it's V, it's equals to pi multiplied by D multiplied by N. So the diameter and the number of revolutions must be given for us to be able to calculate the circumferential velocity. Remember, pi is a given unit there. Important to remember, to convert revolutions, remember if I want revolutions, they are written per minute. I want revolutions per second. What should I do? I must divide my minutes by 60 because I'm taking minutes 2 seconds. So you know that if I've got one minute, then how many seconds do I have? I'll have 60 seconds. Okay, so if I want to convert revolutions per second to revolutions per minute, I must multiply that by 60. So I'm going to have that. Okay, right. Now, activity number 1. Determine the number of revolutions given the following degrees. So the degrees are given. We need to find the number of revolutions in the degree. Remember we said one revolution will be 360 degrees. That's one revolution. So if I've got the whole cycle there, the revolution is 360 degrees. Now I need to find how many revolutions do I have in 180 minutes. I can see some of you are saying this is easy because that will be half of 360, which is correct. So if I say one revolution equals to 360 degrees, and then I'll say 180 degrees will be X revolutions. So meaning that I can then try to cross multiply that and say X multiplied by 360 equals to 180 degrees multiplied by 1. Okay, now I need to find the value of X. So X will be equals to 180 degrees divided by 360 degrees. And I'll get X equals to 0.5. And this will be revolutions. Okay, but I did not need to do all this. What I needed to do was to take 180 degrees and I divide this by 360 degrees because I know that the degrees that I'm having there is 180 degrees. I need to divide them by one revolution and my answer was going to be 0.5 revs. Okay, revolutions. All right, 45, same thing. I can do the same with 45. What should I do? I'll say 45 divided by 360 degrees. I take 45 and I divide it by 360 degrees, and my calculator will give me something like 0.125. All right, so it will give me 0.125. So when I want to change the degrees to revolutions, this is what I do. Remember, this is so important. Conversions are also very important. I've dealt with conversions in the first lesson on circles, angles, and angular movement, and this is just a revision and to check how do we change the degrees to revolutions and revolutions to degrees. Okay. All right. Now let's do some activities that are. This is an exam type question, and this is how they set the questions in the exam. Now, activity 2, a fan, we all know a fan. A fan has a rotating blade with a radius. Now, here it is given, it is a radius of... Now, it is very important that you check the units that have been given. In this case, I'm given meters. And it's a radius. That rotates at 6.3 revolutions. You see, this is revolutions per second. So it is given per second, no problem with that, because I need to find out what the question needs. So now, remember we said the velocity there will be calculated as in seconds. So we say rotate at 6.3 revolutions per second. Now the first question says, calculate the angular velocity in radians per second. In your formula sheet, the formula is given. And when it is given, it is written, angular velocity formula. So the angular velocity formula, it will be this omega, it's not a W, please. Omega, it's equals to 2 pi n. Now, that is the formula for finding that. Now, we know we have another formula, which is omega equals to theta over t. In this case, this formula will not be applicable. Why? Because we don't have an angle. And we are not given time. So here we are given the number of revolutions, which is good. I like it. And they say it must be radians per second. I love that because now we are given that as in seconds. So now I'm going to now substitute my 2 pi into. So the only thing that you substitute in angular velocity, if you check this, it will be your number of revolutions. So that will be 6.3 revolutions per second. I'm fine with that. So if I can take out my calculator, calculate it, I'll have 2 pi multiply by 6.3. And the answer that I'll get there, it will be 39.58. And I must write my radians per second so that I show the people who are marking that I understand that the angular velocity will be measured in radians per second. Okay, so I'll have radians per second as my final answer, 39.58. Remember, in our calculations, we write this correct to 2 decimal places unless stated otherwise. So in this case, it is not stated. I have that. Now let's look how that can be marked in an exam. So when we mark this, I'll mark with green. So when we mark this, the first mark will go to the formula. So you can see how important for you to choose the correct formula. The first mark will go for the formula. The second mark will be going for the substitution of the 6.3. So you'll get a mark for that. And the last mark will go to your final answer, which includes your units. So please, let's all write the units as we have them there. So we have our units as radians per second. All right. Now, the next activity that we're going to be looking at now will be, it will be the same question, but now we're going to be looking at B, and you have guessed it right. We are going to now be looking at the circumferential velocity. So we're still dealing with the same fan, but now we are now looking at the circumferential velocity. So how do I get, so remember it is in meters per second. So it is in meters per second. Now if I can just quickly go back to my question there. Remember the question was given as meters and we have seconds here. So in other words, we are going to get it as meters per second. So how am I going to do that? I know my radius is 0.6. The rotation is 6.3. So now I'm going to now substitute. Now my formula, remember circumferential velocity formula, which is going to be pi multiplied by d multiplied by n. Okay. Now the first thing, remember, what you need to do is to write down what is given. So do I have a diameter? In this case, no. I do not have a diameter because I have a radius and I know a radius that was given was 0.6. So it means that my diameter will be 0.6 multiplied by 2. So I must multiply my radius by, my radius by 2 for me to get the diameter. So for me, for my diameter there, it will be 1.2. So I'll have my diameter as 1.2 meters. You see the trick there was they've given you the radius. Now they request you to get the diameter. Okay. Now the number of revolutions I do have. So how am I going to write that? So I'm going to say the pi multiplied by the diameter. So what will be my diameter there? We said is 1.2 meters. So I have my number of revolutions, which is 6.3. Then I'm going to take out my calculator, and I'm now going to calculate my pi multiplied by 1.2 multiplied by 6.3, and then I'll have my answer, and I want my answer in decimals, which is 23.75. And remember what I'm going to write as my answer, my units for the answer, it will be meters per second. Because my diameter was in meters, my revolutions was in revolutions per second. So therefore I have seconds there, so my answer will be like that. So the 3 marks, how do you get your 3 marks? How do you get your 3 marks there? First, your formula. Very important. Secondly, your substitution. Then you have your final answer, and then you have your 3 marks. Okay. All right. Getting right along. Now, let's look at that activity number 3. With activity number 3, I'm only going to do A, and I'll request you to do B. So I'm going to do 1A there, and I want you to do 1B. Now, let's read the question. So the question says, a wheel of a car has a diameter of 600 millimeters. See, and it rotates at 1,200 revs per minute. It's very, very important that you underline those words so that then when you look at the question, you must then understand what is it that I must substitute and how must I substitute that. It's not just a question of substituting into the formula and then you're going to get it wrong. Now, let's look at it. The first question says, determine the circumferential velocity in meters per second. You see now, that part here is given in millimeters. This part there is given there in minutes. So meaning that I need to change this millimeters to meters. I need to change that minutes to seconds. Then I'll have got my answer correctly. Otherwise, if I just substitute that 600 and the 1,200 and I substitute them there in my formula, then my answer is not going to be correct, because then I will not get meters per second, I'll get millimeters per minute, because then I'll have millimeters and I'll have minutes. So I'll have millimeters per minute. Now, in this one, so I'll have my circumferential velocity. Remember the formula is pi times d times n. Now, the pi, we know, now we need to substitute our diameter. The diameter is 600. What do you think we must do there? We must take the 600 and divide it by. Now, from millimeters to meters, then we are going to divide this by 1,000. Now I'm going to multiply by number of revolutions that is rotating at 1,200 revs per minute. Now how am I going to do that? I know that if I want to change my minutes, I want to change my minutes to seconds, I'm going to divide this by 60. Okay, so now my answer there, it's going to be, then I can see that those 2 zeros will cancel out. I'll have that cancelling out. 6 there goes once, 6 there goes 2 times, and then we have a 0 there. Okay, and then I think that 0 and that 0 will cancel out. Then I can just quickly use my calculator to do that. Pi multiplied by 6 multiplied by 2, and that answer there will give me 37.8 meters per second. Don't forget your units, right? It's also 3 marks there, but I think for me, I can give you more marks on this one. I think this deserves some marks here because you have changed, you have done your formula, that's correct. You have put in you have changed your millimeters to meters, which is good. You have also changed your minutes to seconds, which is good. Then we can have that, and that we then can have 4 marks. We can add a bonus mark there. So your bonus mark there is for you to change that, because you need to change. So the whole thing there, and the substitution is correct, and everything is correct. Then you have your answer. So as I said, the next question B will be for us to do that. And I think 3 minutes will do for us to do that question B, the angular velocity, radians per second for that matter. Okay, right. Let's see what you have done with the angular velocities. Now, with the angular velocity, as I said, the answer must be in radians per second. So here we are given revs per minute. So what should we do there? We must change that to seconds. So remember, our formula is the omega sign equals to 2 pi multiplied by number of revolutions. So in this case, this is not going to work because we're not going to use any diameter for the angular velocity. So I'm going to have 2 pi, but the number of revolutions is the one that will change, which is going to be 1,200 divided by 60. Then we get our answer. This one is going to be 3 marks. So the answer that we get there will be 125,66. It will be radians per seconds or revolutions per second. So the mark allocation there, the mark allocation for that will be 1 mark for that, 1 mark for this, and 1 mark for that. So the 3 marks will be fine there. Okay, so now we have, because we already given you a mark for that one, for changing that one, we won't give you another mark there. But this one is for the substitution. So when you're dealing with this type of question, make sure that you get these answers right. So if you see the word circumferential velocity, you must know which formula to use. If you see the word angular velocity, you must know which formula to use. Because the formula is there in the formula sheet. Please put your formula sheet next to you, and then from there you write the correct formula, then you substitute correctly, and then you can see the tricks that they do, the examiners do. They give it to you in millimeters, and then they want it in meters. They give it to you in minutes. They want it in seconds. So please note the two. Right. Here's a very interesting question here. Now, it says a train moving on a circular track. So that's a circular track with a diameter of 243 kilometers. Takes 50 minutes to complete 1 revolution. By reading this question, you can see that this should be a very fast train. Should be a bullet train. So meaning that it has a diameter of 243 kilometers and takes only less than an hour to complete that 1 revolution. So in other words, we want to find out what will be the speed, the speed of the train for it to complete that circular track in only 50 minutes. So let's look at this. Now, in this case, the distance, which is a diameter, it's given as in kilometers. So I'm fine with it. Okay, it's nice. So that one here, oh, I have problems here. Now I have minutes, and here I have hours. You see that? So it means that I must take this minutes to hours. And it's per hour. So I must change that. So for me to change that, remember I need a peripheral velocity, for which the formula is V equals to pi multiplied by D multiplied by N. So I need that number of revolutions, that time there, which is the number of revolutions there. So what should I do here? So I must take, because it's per, so it's 1 over. So it will be 1 over 50, and I must multiply this one by 60. So that's where I'm going to get the number of revolutions in there. So how am I going to get there? Remember, it takes 15 to complete a revolution. So in other words, that will be 1,2. So I'm going to have 1,2 rev per hour in this case. You see, because it's revolutions per hour. So my N now it's going to be 1.2 rev per hour. So now I've got the revolutions. I don't have a problem. I'll have pi. It's multiplied by my diameter. It's in kilometers, so I'll have no problem with that. Now the number of revolutions will be 1,2 revs per hour. Remember, I need kilometers per hour. So I'll have pi multiplied by 243 multiplied by 1,2. So if I multiply that, I have 916 kilometers per hour, which is the speed of that train. So can you see, For it to complete the circular track, which has a diameter of 243, it needs to be traveling at 916 kilometers per hour. This should be a bullet train because that speed is very fast. Okay, so these are, as I say, applications to the work that we are doing on circles, angles, and angular movement. So when you're dealing with this type of questions, you must read the question, understand the question, and the best thing to do when you are doing that question is to write down what is given. This is 243 kilometers. So the n and that, the pi we know, it's fine. The v is the one that we do not know. And then we then calculate the value of v, which is good. Right, now, the next activity, that activity 5, I'd like to have you do that activity number 5, but let's quickly go through it before you do it, so that then you understand what you're going to do. Now it says a pulley, so there's a pulley in there, right? So there, rotates at 1,800 revs per minute. You see it is written per minute. Now it says calculate the diameter. In this case, what do we need? Now we need a diameter. So we need that diameter of that pulley. In millimeters, if the peripheral velocity of a pulley is given as 18.5 meters per second. So now, the meter, this is given in meters, but we want the diameter to be in millimeters. So can you see the tricks here? So what should you do? You need to find, because the peripheral velocity is given, you must now understand that. You must write down the formula that has to do with peripheral velocity or circumferential velocity. And then from there you calculate the diameter of that pulley. So I want you to quickly do that and give me the answer in millimeters as per the question there. Okay, now let's continue with this question. Now it says a pulley rotates at 1,800 revs per minute. Now we need to find the diameter of the pulley in millimeters. If the peripheral velocity of the pulley is 18.5. So how am I going to do that now? So I'm going to then say, first of all, I must then write down the formula. So my formula for peripheral velocity is pi times d times n, which is the number of revolutions. So the number of revolutions we have it there, it's 1,000 revs per minute. Remember, it's per minute. And here it is written per second, so meaning that we must change something there. So the velocity is given. So what should we do now? We write down what is given there. It's 18.85. Remember, that is in seconds. So which means that my revolutions there must also be in seconds. So I cannot write them in minutes. So how do I write them in seconds? So it will be 1,800, and that is divided by 60. So multiply by the diameter, which we don't know, and then multiply by the pi. Okay, so remember now we're looking for the diameter, but the diameter must be millimeters, so not meters. Remember, this is in meters, and we need to change that one to millimeters. So the answer that we are going to get here, calculating here, it will be in meters. So when we get the answer in meters, we then change it to millimeters, and that is your last mark of the last mark that you're going to get on that. So 18.85. So we're going to say 18.85. Then we're going to divide this by that. So now I'm going to cancel out that. That will be 3 there, and I think it's 0. So in other words, we're going to divide that by 30 multiplied by pi. And that is what we are going to get as our diameter. So our diameter, it's going to be, if I work this one out, then the answer becomes 0.2 meters. Remember, this is in meters. So therefore, we have 0.2 meters. And now how do I change my meters to what is requested here? So what is requested there? It's millimeters. So therefore, if I stop there, I'll only get 3 marks. But then I need to answer the question. So the question says the diameter must be in millimeters. How do I change millimeters to meters? If you know your metric system correctly, then you know that if I've got meters, from meters to millimeters, then I must multiply by 1,000. And if I multiply that by 1,000, I'm going to get 200 millimeters. So the diameter, meaning that on my pulley, my diameter, it's 200 millimeters there. So the diameter, we now know the diameter of that pulley, which is 200 millimeters, because we knew the speed at which it rotates, and also we know the rotation per minute. Then we wanted to find out what is the diameter. So I think that makes sense. So in a workshop, this is exactly what you'll be doing, calculating stuff like that, to say now we've got this thing rotating at 1,800 revs per minute. Then from there we have that velocity, the speed is 18.85 meters per second. Let's calculate what is the diameter of that thing, and then from there we can be able to do it. You see, and this is so easy. And then from there, after finding the diameter in meters, they want it in millimeters, so that maybe you can cut out whatever material you need at the workshop to do that. Right. Now, the next activity, we'll do this together. Now, it says a shaft has an angular velocity. You see, underline every concept that you have there. So, a shaft has an angular velocity of 125 radians per second. So, you see here, you are given the angular velocity. So, that shaft has an angular velocity at that radians per seconds. Now determine the time. Now in this case here they want time that it will take to complete 350 revolutions. It means now we need the time that will take for this shaft to rotate to complete 350 revolutions. So we need the number of revolutions there. So the angular velocity will be was given. So remember the formula for the angular velocity. Remember we have got theta over t, of which we don't have an angle, we don't have time here. So now if we've got an angle, then we'll be able to do that. So there we have 2 pi multiplied by n. So what are we looking for here? We are looking for n. Okay, first we're looking for n, but we remember we need time. N is not time. Okay, now what are we going to do here? We have the angular velocity given as 125 radians per second. We have 2 pi here. We have the n, which we don't know. Okay, so now we're going to say for us to find the n, we must have 125 divided by 125 divided by 2 pi. So we have 125 divided by 2 pi. So the answer that we're going to get there will be n is equals to 19.89436. Right, that is radians per second, revolutions per second. So we have the revolutions per second, but now remember what do we need here? We need to find the time it will take to complete 350 revolutions. The 19.85 is the time to take to for the 125 radians per second. But we need the time when to complete the 350. So how am I going to get the time? This one we know. So we need the 350 revolutions divided by the 19.89436 revolutions per second. I'm writing the unit so that you can see that the answer that we are going to get must be in seconds. Right. So the time we're going to work in seconds because here we are having seconds. There's no way that they talk about anything that we need to change like minutes. So here you can see the revs, we'll cancel out the revs. So I'm left with 1 over s, which is the same as s there. So now here I'm going to have 350 divided by 19.89, and that will take 17.59 seconds. So in other words, this thing is too fast. So it rotates, it will complete 350 revolutions in 17.59 seconds. Okay, so that is how we do that question. So if you stop there, you're only going to get, let's see how we're going to allocate marks on this one. You have a formula for that. Okay, you have the substitution and finding the value of n. Then to tell us that the time is 350 over 19.89, and then also to give us the final answer, which is going to be 5 marks. 5 easy, straightforward marks that you must get. So you can see how we do this question. Remember why I did not round off there? Because I still need to use that answer going forward. So if I round up there, my answer there will not be accurate like the one I'm having here. So meaning that if I'm doing something and then I get an answer, then I'm still going to use that answer. Please do not round off, because then the other answer you'll have rounded off twice. So you need to round off at the end. We always round off at the end when we are getting to our final question, our final answer. Okay, That is a quite a nice question. Now the next question also will also be done by yourself here, but we are going to also, I'm also going to explain how we're going to do that question. It's got two pieces. You're only going to do the first part. I'll do the second part. Now let's go through the question. This one will also be 3 minutes. Now it says the circular blade on a saw has a diameter of 2.32 meters and it rotates at 4,800 revolutions per minute. Can you see these questions are basically more or less the same? Because we are dealing with, you know, the angular velocity, circumferential velocity. Those are the two things that we're dealing with. And also we're dealing with the conversions because they're very important. See, I'm also putting in the conversions in there. In this case, they say it's meters and rotate that one per minute. So let's see what they want to answer. So they want the question there. The angular velocity is obviously radians in seconds. But now remember when we have seconds here and we have got minutes here, we must do something about that. So I've got minutes here, I've got seconds here. So it means that the minute that I'm having there, I must then change that minutes to seconds because I don't need that in seconds. Okay. All right. So now the first one, as I say, it is for you to do because we need to calculate the angular velocity of the blade in radians per second. And this question is for you, and it's also a 3-minute question that you need to do. Your 3 minutes, it's starting now. Okay, now Activity 7 says, hope we have done that. We have a diameter given as 2.32 meters and rotating at 4,000. Remember we said per minute. That is why we are dividing. We must divide. So we're going to say our angular velocity is 2 pi multiplied by n. Now, what are we looking for here? So we have 2 pi, we need the angular velocity. So we have 4,800 revolutions. Remember, it is per minute. So per means we need to divide that one by 60. Okay, so we need to divide that by 60. So please do not multiply by 60 because we want to take the minutes to seconds. Okay, or please divide by 60. It's per minute. So here we need it per seconds. So here I'm going to have 2 pi multiplied by 4,800 divided by 60, of which it will be 2 pi into, I think that goes 8 times there, so we have 80, and then we can multiply this by 80, and then I think the answer will be 502.65 radians per second. You see, now that is what they want here. They want us to do that, radians per second, and maybe if we can look at the marks on how we're going to mark that. That will be 1 mark for the formula, 1 mark for changing this to seconds, and then 1 mark for this, and I think 1 mark will be for the simplification there. Okay, simplify that, and even if you from the calculator here, then you go to your final answer there, because we want to see the final answer after your substitution. So you substitute and then you get your answer. Remember, even if you come here and do that, and from there we've got 2 pi into 4,800 without writing the formula, and then you get your final answer of 502.65 radians per second. Then you're still going to get your full marks without writing the formula. Okay, so we'll mark that one as 2 marks because there we know once you have substituted, it means that you know your formula. Okay, but we want you to practice this by writing down the formula so that you understand which formula is for what. Then you write down your formula and then you substitute correctly and then you use your calculator correctly and then you are able to get to your final answer of 502.65. Okay, so that is your angular velocity of the blade. So in other words, the activity here, 7 here, continue with the same question there. Calculate the circumferential velocity of the teeth in meters per second. You see, they will always give you what you're supposed to do. So in this case, it is meters per second. So we wanted it in meters per second. So the circumferential velocity is, you know, the formula. It's pi multiplied by d multiplied by n. So how am I going to substitute that? So remember, my diameter, if I can quickly go back here, my diameter is 2.32 meters and it's rotating at that. So I've got my diameter, I've got my number of rotations, so that I can be able to do that second question. So substitute there, I'll have my pi multiplied by my d, which is 2.32 meters. Then I've got my number of revolutions. Remember, they also wanted in meters per second. And if I check my question here, the diameter is given in meters, no problems there. And this is given per minute. There's a problem there because I need to change that one to seconds. So I'm going to say that will then give me 4,800. And then I'm going to divide that by 60. And then from there, I'm going to have that as pi multiplied by all this. Or I can just write down the final answer. You can just take a calculator and say pi multiplied by 2.32 multiplied by 4 4,800, divide that by 60, and then the answer that you're going to get there, it's going to be 583.08. Don't forget, this is meters per second. What is another way of doing that? If I do that, if I don't change this, and I say it's 4,800, I put it as 4,800, I'll get my answer in meters per minute. Okay? After getting it as meters per minute, then I can then divide everything there by 60. So what I'm saying is, I can have my formula like that, pi d times n, then I can have my pi, and my d is 2.32, then I put 4,800 here, then I multiply my whole question. If I take my calculator, but pi multiply by 2.32 multiply by 4,800, and the answer that I'm going to get here, it's going to be 34,984.77. Then from there I can then say that answer must be divided by 60. If I divide that answer by 60, then the answer that I'm going to get will be, because I have to divide this by 60. Why I divide it by 60? Because I want to take this answer to seconds, and the answer that I'm going to get is 583.08, and that answer will be the same as the one that I'm having here. So you can either do that question and then go down here and then divide that answer by 60. The only thing there is that you must not forget to divide by 60. Because once you forget to divide by 60, that answer will not be correct. Because you'll have that final as your final answer, and that will be incorrect. Okay, I think we are doing very well. Right, now, here is a very nice question here. Now it says an outboard motor pictured below. There is the picture of the outboard motor. It's used to propel the boats through the water and has a 4-stroke engine. Right? At a cruising speed, the engine causes tips of the propeller blades to rotate. Okay. At a circumferential velocity, see, this is where my information is, of 30 kilometers per hour. You see, now it says it is propelling, it's rotating this, the propeller blades here are rotating at a circumferential velocity of 30 kilometers per hour. The diagram alongside depicts the circular path formed by the rotating propeller blades. See? And the radius, very important, of the circular path is 180 meters. So if it's 180 meters, which is the radius, and I've got a circumferential velocity, so here it is. Now I can then come here and write and just put here the formula for circumferential velocity. So I just write down my little formula there for the circumferential velocity. So I already know that the circumferential velocity is 30 kilometers per hour. The diagram alongside, as I said, now the radius there, I have my radius, and of which, obviously, what do I need here? In my formula, I don't have a radius. So what do I need? I need a diameter, so I can just come here and say, okay, the radius is 180 meters, but I need a diameter, so my diameter is going to be 360 meters. So that's my diameter. So remember, the diameter will be 2 times the radius. They haven't asked me those questions yet, but I'm just working on my statement there, because it's very important that we read the statement, work through your statement, and then work through your statement and get what is given and get a formula for that statement and try to see that you have everything that is given on the statement. So the diameter thing, I'll be fine with that. The number of rotations, if they ask me about that, so I'll be able to can get that. So now the question says, now convert 30 kilometers per hour, which is a circumferential velocity. Remember, this is a circumferential velocity, 2 meters per second. So you can see the conversions are very, very, very important. So I need to convert that to meters per second. So now how am I going to convert first to meters? So if I want to convert 30 kilometers and I want to convert it to meters, remember I'll have millimeters, centimeters, decimeters, meters. So I want to convert my kilometers, so I'll have my decameters, I'll have my hectometers, and then I'll have my kilometers. So I want to take these kilometers there. Okay, so what am I going to do to do that? So I'll have, remember when I go up, I'm going to multiply that. So I'm going to say 30 multiplied by 1,000. Because from here to there, it will be 1,000. So I'm going to multiply that by 1,000. So I'm going to get, remember now I'm having it as meters. So I'm going to have 30,000 kilometers. But remember it's with seconds. So remember I'm taking it from hours, I'm taking it to seconds. So I'm taking it here to seconds. So how am I going to take my hours to seconds? Remember from seconds I go to minutes, and from minutes I go to hours. So now I've got my seconds. I'm having my hour, which is 1 hour. I want to change my 1 hour to seconds. So for me to change my hour to minutes, it's 60 minutes. So meaning that I'm going to divide it by 60 if I change it to minutes. But for me to change it to seconds, I must also divide it by 60. So I'm also going to divide that by 60. So meaning that I'm going to have 30,000 divided by 3,600. So if I divide, these zeros will cancel out. Okay, I'll have 300 divided by 6. And how am I going to get 300 divided by 6 there? So I'm going to have the answer there is going to be, sort of divided by 36. It's 300 divided by 36. Remember, 6 times 6 is 36. So I'm going to divide that. So my answer that I'm going to get will be 8,33 meters per seconds. Remember, this is not, so this is meters, it's not kilometers, sorry. Just erase that. So that will be meters. Remember, we have changed it from kilometers to meters. And then here are seconds. So it becomes meters per second, and 8.33 meters per second will be our final answer. Okay, I took time on that question because the conversions are very, very important. Once you cannot convert that, the second question that comes here will be talking to this, and you cannot use kilometers per hour because the question will need you to write it in meters per second. So it's very important that we know how to convert. Okay, now, hence, you see the word hence now means that use what you got in the previous question to do that. So it says the angular velocity. Now you see I'm going to have a challenge here. What challenge am I going to have? To get the angular velocity, if you look at the formula for the angular velocity, it's omega equals to 2 pi n. What challenge am I having now? I don't know what my n is. So I'll have a challenge there. Because according to this question here, you can see in the whole statement there, I don't have anywhere that they gave me the rotation. I mean, sort of the revolutions. So I don't have any revolutions given there. So I'll have a challenge to get that. So now it means for me to get angular velocity, I need the number of revolutions. So to get the number of revolutions, I don't have an angle. If I had an angle, then I'll have used the formula omega equals to theta over t. So I'll have used that. But I can't use that because I don't have an angle. I also don't have time there. So in other words, here, the formula that I have is this one. So that's why the word hence, meaning that I'm going to use whatever I got in the previous question to get to that. Remember in the previous question, we got our angular velocity. Remember this one is, our circumferential velocity. It's given as 8.33 meters per second. So I'll have that as my circumferential velocity. So what I need to do is to then find how to get this question, the number of revolutions that we need. For this question, I'm going to give you this question to do now. I'm giving you 4 minutes to do that question, and then we'll then wrap up with that question. Your 4 minutes will start from now. Okay, now, as I said, what we had there was our velocity. I'm going to write it there. Now we've got our velocity, which is 8.33 meters per second. That's what we have. That is why that question says hence. Already we have the velocity, so I'm going to write down the formula for the velocity, which is pi times d times n, and that's what we have. Do we have a diameter? Yes, we do have a diameter. Now, I'm going to, do I have a velocity? Yes, we do have a velocity. So I'm having 8.33, which is the circumferential velocity. I have pi. I know what pi will be. I've got a diameter. Do you remember? You have a diameter, which is, we have a radius in that question, which is 180 meters. So we need to change that one to meters. So let's check that. It's 180 meters. So we're fine with that. So now, because we need that in meters, so now I'm going to put that as a diameter, as a radius, by the way. The radius is 180 meters, so we need it as that. So I need 360 meters there. And I've got number of revolutions. What will be the number of revolutions there? I'll not have the number of revolutions, but I have all this. So pi I do have. So I'm going to say my n there, it's going to be, so if I take out my calculator, then I'm going to have 8.33 divided by pi multiplied by 360. Okay, so it will be 8.33. Then we're going to divide that by pi. Okay, because I need n here, so then I'm going to divide that by 360. So which is going to be 0.007365. So that will be revs per second. Remember, I'm having that one. Okay, let me quickly go back. Remember, I'm having my radius as 180. My diameter is going to be that because the radius is in meters. Then I need that in meters. So I'll have that one in meters also. So you can see we have that diameter is in meters also. And then our velocity is also in meters per second. And then we have the 360 is our diameter. We have the n there. So this is the number of revolutions that we'll take. Now, from the number of revolutions, how am I going to now get the angular velocity? So my angular velocity is going to be 2 pi multiplied by the 0.7365, because that's what I'm going to have. So I'm going to multiply that one. So I'm going to say 2 pi, then multiply this one by 0.007365. Okay, so my velocity will be 0.046, and that will be radians per second. So that is what I'm going to have. All the other formula that I can use there will be your V, it's equals to your omega multiplied by the radius. Okay, so now I can have my omega, I have my radius is 180 meters. So I've got my velocity there, which is going to be 8.33. Then I can just get my omega. Then I can just divide my omega there, which is going to be 8.33. Then divide this one by 180. And then I'll have my answer, the same answer there, which is 0.046 radians per second. So I'll have the same answers if I do it like that. So remember, if I'm given that type of question, I must use the word hence, means use the previous information that you get from there to do the question that you are having there. So which previous knowledge do you know? It's 8.33 meters per second, which is circumferential velocity. Then I've used it. either on this question, on this one, or on that one, on that formula. So if I use this formula, first I must get the number of revolutions. If I use that formula, it's straightforward. I can just go directly to that. So you must know both formula and you must know how to use it. And this is our last question. I'd like to take this opportunity to thank you so much for watching this presentation, and please go and practice, use your formula sheet correctly. Always have your formula sheet when you're doing these activities. This is a very easy topic. You can score a lot of marks because you have your formula sheet, and then just read the question, understand what it wants, use the conversions that we have talked about, and then check your units at the end when you write down your answers. And thank you very much for watching this video. Thank you.